Okay, welcome back. So in the last lecture, we have talked about the selection and projection for U. And besides them, we also have another basic operation. It's called product of relations. So the product of relation is defined based on a set product, actually. I hope you still remember what is a set product, right? Let's assume we have two input relation, R1 and R2. R1 has a schema with A1 to AN as the attributes, and R2 has B1 to BM as the attributes. And we want to compute the product between R1 and R2. Then the question will be, what will be the output? First, we know the output will still be a relation, right? It is still a relation. However, what about the schema of the output relation? We can formally represent the schema of the product between R1 and R2 as S. S is another relation, is the output relation, right? For the S, it has A1 to AN and B1 to BM as the attributes. You see this, right? In other words, we combine all the attributes from the two input relations to compose the output relation, A1 to AN and B1 to BM. So it's about product between two relations. You see this product can be very expensive because the output relation will be a very big table, right? This is about schema. You may wonder, how about the data tuples? For data tuples, we may have to combine all the instances in R1 with R2. It will be very similar to the set product we showed before. Right? You see this operation is very expensive because the output table will be very huge in both the rows and the columns. Therefore, because this operation is expensive, it is seldomly used in practice. We don't use this product very often. Instead, we prefer to use the joins to help us. Join is more efficient in terms of the cost in both time and space. However, join is actually a more complex operation defined based on the product together with the selection and projection. We will show later. Let me provide you with an example about the product between two relations. Let's assume we have two relations. The first one is the employees, right? Employee has SSN and name as attributes. Another relation we have is a dependent. Now for the insurance, right? If you still remember, it's some work-ended sets. Dependent depends on the employees. Therefore, inside this dependent table, we have both the employee SSN together with the dependent name as the attributes. And here we plan to calculate the product between employee and dependent. So to represent the output, the first step is to decide the schema of the output relation. We know the output will be still a relation, right? It can be denoted by a table. It will have four attributes: SSN, name, as well as employee SSN and dependent name, right? We will combine all the attributes together. We will have four attributes in the output relation, right? Then how about the data tuples? For data tuples, we may have to combine all the tuples in this table with each one in the dependent table. In other words, for the annex records, we have the copies here. And the annex records we need to combine with both Chris and David, right? Here we have annex combined with Chris. Annex combined with David, as shown in the second row. And we may also have to combine the Brandy with Chris and Brandy with David as well, as shown at the bottom. Alright. So you see the output table will be very huge if we have more attributes and more data tuples.